Chapter 11 of the Life of the Spider. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Life of the Spider, translated by Alexander de Matos. Chapter 11. The Garden Spiders, the Lime Snare. The spiral network of the Epeirae possesses contrivances of fearsome cunning. Let us give our attention by preference to that of the banded Epeira, or that of the silky Epeira, both of which can be observed at early morning in all their freshness. The thread that forms them is seen with the naked eye to differ from that of the framework and the spokes. It glitters in the sun, looks as though it were knotted, and gives the impression of a chaplet of atoms. To examine it through the lens on the web itself is scarcely feasible, because of the shaking of the fabric, which trembles at the least breath. By passing a sheet of glass under the web and lifting it, I take away a few pieces of thread to study, pieces that remain fixed to the glass in parallel lines. Lenses and microscopes can now play their part. The sight is perfectly astounding. Those threads on the borderland between the visible and the invisible are very closely twisted twine, similar to the gold cord of our officers' sword knots. Moreover, they are hollow. The infinitely slender is a tube, a channel full of viscous moisture resembling a strong solution of gum arabic. I can see a diaphanous trail of this moisture trickling through the broken ends. Under the pressure of the thin glass slide that covers them on the stage of the microscope, the twists lengthen out, become crinkled ribbons, traversed from end to end through the middle by a dark streak, which is the empty container. The fluid contents must ooze slowly through the sides of those tubular threads, rolled into twisted strings, and thus render the network sticky. It is sticky, in fact, and in such a way as to provoke surprise. I bring a fine straw flat down upon 3 or 4 rungs of a sector. However gentle the contact, adhesion is at once established. When I lift the straw, the threads come with it, and stretch to 2 or 3 times their length, like a thread of India rubber. At last, when over taut, they loosen without breaking, and resume their original form. They lengthen by unrolling their twists, they shorten by rolling it again, and lastly, they become adhesive by taking the glaze of the gummy moisture wherewith they are filled. In short, the spiral thread is a capillary tube, finer than any that our physics will ever know. It is rolled into a twist, so as to possess an elasticity that allows it, without breaking, to yield to the tugs of the captured prey. It holds a supply of sticky matter in reserve in its tube, so as to renew the adhesive properties of the surface by incessant exudation, as they become impaired by exposure to the air. It is simply marvellous. The Epeira hunts not with springs, but with lime snares. And such lime snares! Everything is caught in them, down to the dandelion plume that barely brushes against them. Nevertheless, the Epeira, who is in constant touch with her web, is not caught in them. Why? Let us first of all remember that the spider has contrived for herself, in the middle of her trap, a floor in whose construction the sticky spiral thread plays no part. We saw how this thread stops suddenly at some distance from the centre. There is here covering a space which, in the larger webs, is about equal to the palm of one's hand, a fabric formed of spokes, and of the commencement of the auxiliary spiral, a neutral fabric in which the exploring straw finds no adhesives anywhere. Here, on this central resting floor, and here only, the Epeira takes her stand, waiting whole days for the arrival of the game. However close, however prolonged her contact with this portion of the web, she runs no risk of sticking to it, because the gummy coating is lacking, as is the twisted and tubular structure throughout the length of the spokes, and throughout the extent of the auxiliary spiral. These pieces, together with the rest of the framework, are made of plain, straight, solid thread. But when a victim is caught, sometimes right at the edge of the web, the spider has to rush up quickly to bind it and overcome its attempts to free itself. She is walking then upon her network, and I do not find that she suffers the least inconvenience. The lime threads are not even lifted by the movements of her legs. In my boyhood, when a troop of us would go on Thursdays, the weekly half-holiday in French schools, to try and catch goldfinch in the hemp fields, we used, before covering the twigs with glue, to grease our fingers with a few drops of oil, lest we should get them caught in the sticky matter. Does the Epeira know the secret of fatty substances? Let us try. I rub my exploring straw with slightly oiled paper. When applied to the spiral thread of the web, it now no longer sticks to it. The principle is discovered. I pull out the leg of a live Epeira, brought just as it is into contact with the lime threads. It does not stick to them any more than to the neutral cords, whether spokes or parts of the framework. We were entitled to expect this, judging by the spider's general immunity. But here is something that wholly alters the result. I put the leg to soak for a quarter of an hour in disulphide of carbon, the best solvent of fatty matters. I wash it carefully with a brush dipped in the same fluid. When this washing is finished, the leg sticks to the snaring thread quite easily and adheres to it just as well as anything else would, the unoiled straw for instance. Did I guess aright when I judged that it was a fatty substance that preserved the Epeira from the snares of her sticky Catherine wheel? The action of the carbon disulphide seems to say yes. Besides, there is no reason why a substance of this kind, which plays so frequent a part in animal economy, should not coat the spider very slightly by the mere act of perspiration. We used to rub our fingers with a little oil before handling the twigs in which the goldfinch was to be caught. Even so, the Epeira varnishes herself with a special sweat to operate on any part of her web without fear of the lime threads. However, an unduly protracted stay on the sticky threads would have its drawbacks. In the long run, continual contact with those threads might produce a certain adhesion and inconvenience the spider, who must preserve all her agility in order to rush upon the prey before it can release itself. For this reason, gummy threads are never used in building the post of interminable waiting. It is only on her resting floor that the Epeira sits, motionless, and with her 8 legs outspread, ready to mark the least quiver in the net. It is here again that she takes her meals, and often long drawn out when the joint is a substantial one. It is hither that, after trussing and nibbling it, she drags her prey at the end of a thread, to consume it at her ease on a non-viscous mat. As a hunting post and refractory, the Epeira has contrived a central space, free from glue. As for the glue itself, it is hardly possible to study its chemical properties, because the quantity is so slight. The microscope shows it trickling from the broken threads in the form of a transparent and more or less granular streak. The following experiment will tell us more about it. With a sheet of glass passed across the web, I gather a series of lime threads, which remain fixed in parallel lines. I cover this sheet with a bell jar, standing in a depth of water. Soon, in this atmosphere, saturated with humidity, the threads become enveloped in a watery sheath, which gradually increases and begins to flow. The twisted shape has by this time disappeared, and the channel of the thread reveals a caplet of translucent orbs, that is to say, a series of extremely fine drops. In 24 hours the threads have lost their contents and are reduced to almost invisible streaks. If I then lay a drop of water on the glass, I get a sticky solution, similar to that which a particle of gum arabic might yield. The conclusion is evident. The Epeira's glue is a substance that absorbs moisture freely. In an atmosphere with a high degree of humidity, it becomes saturated and percolates by sweating through the sides of the tubular threads. These data explain certain facts relating to the work of the net. The full-grown, banded, and silky Epeirae weave at very early hours, long before dawn. Should their air turn misty, they sometimes leave that part of the task unfinished. They build the general framework. They lay the spokes. They even draw the auxiliary spiral, for all these parts are unaffected by excess of moisture. But they are very careful not to work at the lime threads, which, if soaked by the fog, would dissolve into sticky shreds, and lose their efficacy by being wetted. The net that was started will be finished to-morrow, if the atmosphere be favourable. While the highly absorbent character of the snaring thread has its drawbacks, it also has compensating advantages. Both Epeirae, when hunting by day, affect those hot places, exposed to the fierce rays of the sun, wherein crickets delight. In the torrid heats of the dog days, therefore, the lime threads, but for special provisions, would be liable to dry up, to shrivel into stiff and lifeless filaments. But the very opposite happens. At the most scorching times of the day they continue supple, elastic, and more adhesive. How is this brought about? By their very powers of absorption. The moisture of which the air is never deprived penetrates them slowly. It dilutes the thick contents of their tubes to the requisite degree, and causes it to ooze through, as and when the earlier stickiness decreases. What bird catcher could vie with the garden spider in the art of laying lime snares? And all this industry and cunning for the capture of a moth? Then, too, what a passion for production! Knowing the diameter of the orb and the number of coils, we can easily calculate the total length of the sticky spiral. We find that, in one sitting, each time that she remakes her web, the angular Epeira produces some 20 yards of gummy thread. The more skilful silky Epeira produces 30. Well, during 2 months the angular Epeira, my neighbour, renewed her snare nearly every morning. During that period she manufactured something like 3/4 of a mile of this tubular thread, rolled into a tight twist and bulging with glue. I should like an anatomist endowed with better implements than mine, and with less tired eyesight, to explain to us the work of the marvellous rope yard. How is the silky matter moulded into a capillary tube? How is this tube filled with glue and tightly twisted? And how does this same wire mill also turn out plain threads, wrought first into a framework, and then into muslin and satin, next a russet foam, such as fills the wallet of the banded Epeira, next the black stripes stretched in meridian curves on that same wallet? What a number of products to come from that curious factory, a spider's belly! I behold the results, but fail to understand the working of the machine. I leave the problem to the masters of the microtome and the scalpel. Chapter 12.